All right. All right. So we have a lot to do today. So let's see. Well, now it turns out that last time I completely forgot to go over the problem sets. So now for each chapter, there's supposed to be at least one problem set. So if you go back into our schedule, you'll see that so far we've gone through chapters 3, 4, 5, and now we're still in the middle of 7. So there are 3 problem sets on Blackboard. In fact, let's go open it up. And take a look. Oops, nope, not there. All right, hold on one second. All right, yes, so for 3, there's a problem set here, which we'll go over today. For 4, there's another problem set, which we'll go over today, okay? And then chapter 5, there is one, we'll save that for Friday, rather. Okay, so Fridays, this problem set involves elasticities. We'll save that one for Friday. How about that? All right, and in the meantime, there's actually some videos, although, oh, here they are. There's some videos. We've already seen some of the videos. I think actually there's one more here that I wanted you to see. Hold on. Let me just double check. And they involve what we were looking at last time, which is to say what happens when there's a change in supply and demand, what happens to consumer surplus. And so the 2 cases we looked at were the price floor and the price ceiling. Now, there's more cases that we need to look at. Let's see, hold on one second. We've seen the consumer producer surplus video. We've got a separate video each for price ceilings, price floors, taxes with deadweight loss. And then there was one more that I want you to see, taxes on producers. Let me add that to the list here. Hold on one second. All right, it's so much nicer to have it all here in one place. Okay, so this way, if you want to watch it again, you can do so. All right. All right, so yeah, we want to watch these. This is exactly what we've been doing. We're about to start looking at taxes. As soon as we're done with this content, we'll be looking at taxes anyway. So we'll go through these videos. But first, let's go back and revisit these problem sets that we, of course, neglected to do last time. My fault, of course. So chapter 3, problem set. Now, this is going back to our discussion about the production possibilities frontier. This is a very simple problem. And all it is a table which shows us how much we can produce of each of these 2 goods. We've got hamburgers and steaks. I don't know. Let me just draw a little sketch of this thing. The problem is that it's hard to draw something like this, but I'm going to see what I can do just so we can visualize what's going on here. Hold on one second. Let's see what this thing looks like. Now, the one thing we have to watch out for is that we're all going to get different graphs if we don't put the same good on the same axes. So it says in the instructions to put hamburgers on the vertical axis. So let's make sure we do that. And steak on the horizontal axis. So if you look at these points, you're starting out with 20 hamburgers and no steaks. And then you work your way down to 18 and 2. And then 14 and 4. And then 8 and 6. Let's try here. Now, it doesn't have to be perfect, and it's not going to be perfect. All right. It doesn't work that way. It'll be a rough sketch. We're trying to show, let's say, that it's curved. It's very difficult to draw this thing properly, believe me. But a rough sketch is fine. And then we have none and 8. Let's put that here. Let's try it. All right, it could have been worse. I mean, really, it's not great. Maybe I could fix this one a little bit. And it's probably good enough. Okay, and then these are the points A, B, C, D, and E. So basically, as you recall, as we move up and down this curve, we can calculate the opportunity cost of producing one good by sacrificing the other good. So for something like that, you can put it into a table. The picture is just there to help you visualize what you're actually doing. All right, so let's say that we take this chart and we add another column to it so that we can summarize our calculations. First, this is one of the nice things about working in Word as opposed to a blackboard. But let's see what we can do here. All right, and then let's make this a little bigger. So what you're looking to do here is calculate the opportunity cost. And this is, by the way, this is part B. A was the graph. All right, the graph is fine. B represents us figuring out the opportunity cost of producing hamburger at each point on the curve. Okay, now when it says opportunity cost of hamburger, that means you're making more hamburger and less steaks. Okay, so in part B, calculate the opportunity cost of hamburger for the entire curve. Okay, so remember the way opportunity costs work. In this case, the opportunity cost of making hamburgers would equal the sacrificed steaks divided by gained hamburgers. Okay, so the thing to remember with opportunity costs,
screen.
Yeah.
There you go.
Numerator is always the sacrificed good, and the denominator is always the gain good. Okay, so as soon as you see the words opportunity cost of hamburger, you know that you're going to calculate this ratio of sacrificed steaks divided by gained hamburgers. But you also recognize that this means that we're going from E to A. Okay, because if we start at E, we only have steaks. Okay, so in order to calculate opportunity costs, of making hamburgers, we must increase our output of hamburgers and thereby reduce our output of steaks. Okay, so in other words, we're moving, I guess, how would you describe that in English? Move from our E to A. How about that? Okay, that's good enough. All right, so as far as the chart is concerned, so here we'll label this the opportunity cost of hamburger. And so what we're going to do is start at E. And now when we're at E, we're going to move up the curve to D. All right. In fact, you know what I could even do? Let me copy this thing. Just again, so you can see what's going on. So that means there's an assumption here that we're starting at point E and we're working our way up the curve, one step at a time. So in the process of going, for example, from E to D, what's happening here is, well, first of all, in the chart, we'll put that here. From E to D, we'll note that to go from E to D, how many stakes are we giving up? In other words, as we go from this point to this point, we're giving up 2 stakes and we're gaining 8 hamburgers. Okay, so the ratio is 2 stakes to 8 hamburgers. So the actual opportunity cost is defined as 0.25, 1/4. In other words, we're giving up 1/4 of a steak to get 1 more hamburger. So it's a pretty low opportunity cost. What happened to these guys? But anyway, the logic is that we're moving from E to D. And then we go from D to C. All right, D to C. And here, just to visualize that you are looking at the stakes. We're losing 2 more stakes. In the process, how many hamburgers are you picking up? This time we're picking up only 6. Okay, we go from 8 to 4. So we gain 6 hamburgers. And so that's let's say 333, 1/3. All right, now we go from C to B on this curve. So when we go from C to B, we are losing 2 stakes. And you notice in this table, it was set up that way on purpose. The loss is always the same. It's the denominator that keeps changing. And this time when we go from C to B, we only gain 4 hamburgers. So the ratio is 0.5. Okay, and then finally, we move up to the very top from B to A. We lose 2 stakes again from 2 to 0, but this time we only gain 2 hamburgers. Well, that suddenly brings us up to 1. Okay. All right, now the key detail here is this. First of all, we have the numbers. But as we move up the curve, if you notice, from the bottom to the top of the chart, that is, the opportunity cost of making hamburgers is getting higher and higher. Okay, so we'll make a note of that down here somewhere. My graph got messed up somehow. Look at that. There it is. All right, so the bottom line here is that as we move from E to A, we must continue to give up 2 steaks to get more hamburgers. The number of hamburgers gained continuously declines or decreases so that the opportunity cost of producing more hamburgers is steadily increasing. Okay, so this is true of any curved production possibilities frontier. You may recall we mentioned that earlier on in this chapter, and I'll just put a note here. Opportunity costs would be constant if the PPF was a straight line. And we haven't actually seen too many cases of that because in practice, these PPF curves typically are curved because opportunity costs tend to increase in the real world. But in some cases, like let me show you a case where you would have a straight line. And by the way, none of this was asked for in the problem set. I'm just throwing this in there for your benefit. The question never said, show me what happens with a straight line, but I want to do it anyway, because I think this one will make a lot of sense to you. Example of a straight line PPF. Now imagine that here's my chart. let's see. Let's grab this chart and do something a little different with it. So you got points A, B, C, D, E. And then over here we'd have hours of sleep and hours of being awake. Okay, so here you can see, obviously there's a direct trade-off. So no sleep means you're awake 24 hours to, okay, I mean, you kind of get the idea here, I hope. And I could carry that on down. And you can see this is a different case altogether because there's only 24 hours in the day. If I, in order to sleep one more hour, no matter where I am on this line, I must sacrifice 1 hour of being awake and vice versa. Therefore, the opportunity cost of sleep is always 1, no matter where we are on the curve. That would be an example of a straight line production possibilities frontier. It's a direct trade-off between the number of hours you can spend in each activity. And you notice I didn't fill in every single possibility, but these are I guess I put in the sensible ones. These are the possibilities, except maybe these two are kind of out of these you don't want. Even this one's kind of dubious, but still they're possibilities. So anyway, but here, this is more normal in the real world because the reason why this is happening is because while hamburgers and steak are similar products, they're not identical to each other. You're not typically getting them from the same part of the cow, and they're not produced in exactly the same way. So while they're very closely related, there's a limit to how far you can replace one with the other. Okay, and that's why this curve is curved, because the resources are not perfectly, as we say, substitutes for each other. All right, so let me just mention that here too. The reason why the PPF is curved is because the resources being used in the production of hamburger and steak are not what we would call in economics perfect substitutes. Okay, so in other words, there comes a point where you can only squeeze so much out of your resources. It's kind of like farmers growing crops on their land. Not all the land might be equally suitable for both, let's say, corn and wheat, and so they're not perfect substitutes for each other. So you might get a curved production possibilities frontier. And for the most part in the real world, that's what you'll get. But there might be very special cases like this one where you're going to get a straight line. Okay, you get, for example, you can imagine what this thing would look like. Well, you have to draw one, at least a sketch, at the very least, just something like this. And just to show that you understand what the shape looks like, that's as good as it has to get. I'm not asking you to be artists. I mean, it would be nice if you could make it more accurate, but as long as you can show the curvature and which belongs on each axis, that should be fine. So don't panic. I did say this is hard to draw properly. It would just be a little sketch, that's all. But for the sleeping and the being awake, oh yes, absolutely, yeah. No, don't worry. This is not an art class. It's like with the supply and demand curves. Yeah, I know that not everybody is artistically inclined, but if you can, all you have to be able to do is show straight lines that are moving around, and that should be enough. All right, so here you would put, let's say, sleep on the vertical axis and awake here. And then, you would obviously, both of these would start at 24 hours. And then, you would have like combinations like, let's go down here, let's say 8 and 16. And then, oh my God, this is going to be tough. I'm going to try to draw a straight line through here. Woohoo. That's not so bad. It could have been worse. And, oh, sorry, this is not 18, this is 8. That could be, for example, yeah, one of your choices. And so, but you can see it is a straight line because let's say, I don't know, let's say it's Saturday and you're really tired. There you go. So you're going to now be at 14, that kind of thing. So that's a straight line. PPF. Whoops. And that implies, and I mean, you can see that there is an opportunity cost to being asleep. Whatever, let's say you spend another hour in bed, that's another hour of other activities that you cannot pursue because you only have 24 hours a day, no matter who you are. That's it. You get 24 hours and that's it. So then, of course, you have to make a tough decision. Well, is it more sleep more important than having another hour of fun or something, or getting work done? All right. So now, with all that being said, now what remains to be done is to take this curve, this box rather, and go the other direction. In other words, we've seen the case where we start with all steaks and we move our way up to all hamburgers. Now we're going to do exactly the opposite. Okay, so we're going to actually move down the curve now. This is part C. All right, so I'm going to go grab another copy of this production possibilities curve. Except this time I'm going to change the arrows. Okay, so in other words, in part C, we're being asked to calculate the opportunity cost of producing steak. Okay, all right, so let's get that done. So in other words, this one means that we're moving in the opposite direction. Okay. So we start at A, and we work our way down the curve. So from A to B, oh, I have to still add one more column here. So the logic is exactly the same. From A to B, we have two, in this case, as we go from A to B. Now, because it's the opportunity cost of steak, we always put in the numerator, what are we giving up? All right, so just like up here, we're going to list the number of hamburgers that we had to sacrifice. And then we're going to list the number of steaks that we gain. Okay, so sacrifice burgers go on the top. That's 2 hamburgers we had to sacrifice to gain 2 more steaks. All right, so in other words, you see from A to B, we're reducing our hamburger output by 2, but we're also gaining 2 steaks. So that means the ratio is 1. Whoops. I'm trying to make the chart a little more pretty. There we go. All right. Now from B to C, you'll notice that we lost 4 hamburgers while we were gaining 2 steaks, which is a ratio of 2.0. So from B, 18 to 14. Now from C to D, we're losing 6 hamburgers now when we go from C to D, and we're gaining 2 steaks. Ooh, man, these opportunity costs are rising very quickly, aren't they? Yes, they are. Okay. And then finally from D to E, we lost 8 hamburgers this time in order to get 2 more steaks. And that's 4.0. So now this time, if we go from A to E, you'll notice that we keep losing more and more hamburgers. So just like in the other case with the steaks, so as we produce more and more steak, the opportunity cost in terms of sacrificed hamburgers continually increases, which is exactly what we would have expected. Okay, because it's a curve, this has to happen. And again, I'll just make a note here. This is true of all curved production possibilities frontiers. By the way, I just want to point out, interestingly enough, now the curves that we've seen either come in one of 2 forms. We either have a curved one or we have a straight line. And so this one is sometimes said to be concave, concave to the origin. You might remember that from high school math. Concave to the origin. You don't have to remember this. And this, of course, is a straight line. The one thing you can't have with these things, you'll never see something like this. Okay, this one is said to be convex to the origin. And so we'll note here that a PPF can't be convex because then opportunity costs would actually be decreasing. And that's not possible in the real world. I thought I would just throw that in there in case you were wondering. It's got to be the concave version or the straight line. It cannot be convex because that would imply decreasing opportunity costs, and that doesn't happen on this planet of ours. Okay, so that I think is all we need to say about opportunity costs for now and production possibilities curves. All right, well, that was a good review, I think. Now we still have another one here, which is about supply and demand. Oh, by the way, I did want to mention one more thing. I almost forgot. It almost got away from me. It is because opportunity costs typically increase when producing a product, the producer will require a progressively higher price to produce more units of the good. So in a nutshell, this is why the supply curve is upward sloping, because of increasing opportunity costs. That's the actual reason why this is happening. All right, so there you go. That's what the issue is. That's why in order for us to make more products, we expect to be compensated for it because our opportunity costs are going up. And so we're only going to make more of a product if the price goes up. And that's it. So people want more of a product, they can have it, but they have to pay a higher price for it. All right. Okay, I think we have enough of that one. Now, the next one, chapter 4, was a discussion about supply and demand. Good. That is unquestionably the most important topic that we'll encounter. And so you'll notice that everything that we do in economics is really ultimately based on supply and demand. It couldn't be more important. So let's go get that one open and see what this one is all about. This is the chapter 4 problem set. All right, let's make that a little bigger. All right, now in these first 4 questions or 4 parts, it doesn't say to draw the curves, but you might want to do it anyway, just because it might help you visualize what's going on. All right, and honestly, it's good practice too. So let's try these. So all we're being asked to do is say, listen, once you're in equilibrium, what's going to happen to price and quantity if one of the following factors changes? All right, hold on one second. All right. So the increase in demand means the entire demand curve shifts to the right. So we'll have our usual upward sloping supply curve, downward sloping demand curve. At the crossing point, let's call that 1 because we're going to have a second equilibrium as well. We'll identify these as P1 and Q1. And so the demand curve shifts to the right as a result of that increase. And it doesn't matter why this is happening. What matters is that you can see that the price went up and the quantity also went up. I'm using these little arrows as shorthand to indicate that they both went up. In other words, the sellers will make more of this product that the people clearly want, but only at a higher price. If you want more, you have to pay for it. It's like anything else in life. You can have whatever you want as long as you're willing to pay for it. And the more you want of it, the more you have to pay. It's just that simple. All right. Now, decrease in demand, you obviously will have everything working in reverse, but let's go ahead and draw the picture anyway. All right. Just like I said, because it's excellent practice. And, you don't have to be a Picasso to do this. Just if you can draw straight lines, you can do this. Just make sure it's clear. All right. Try to, make it as neat as possible. I run into that sometimes with these curves. I get people who, well, let's just say that it's not the neatest thing I've ever seen in my life. As long as it's clear, that's the bottom line. All right, so let's see what a decrease in demand would then look like. Okay, so just shift everything to the left, or shift the demand curve to the left. But I'm sure you can already predict what's going to happen. It's just the reverse. So we started here. And then we shift down here. That's our new equilibrium. There's been no change in supply. So the price went down and so did the quantity. Actually, what I could do is sneak in another arrow right here to remind us that that curve shifted to the left. And same thing up here, a reminder that the curve shifted to the right. All right, so the increase in demand shifted the curve to the right, the demand curve, and we increased both the price and quantity. A decrease in demand means the demand curve shifts to the left, and now both the price and the quantity both decrease. All right, for C, there's an increase in supply. Now this one is different because if you notice up here, the price and the quantity are both moving in the same direction. That's always the case when demand changes. But when it's supply, ooh, things are different. Let's see how. Let's move this down here to give me some room. So supply goes up. And of course, by the way, I almost forgot to mention this too. In these cases, the word increase always means something shifts to the right, and decrease always means it shifts to the left, whether it's supply or demand, it's the same thing. So here then, the supply curve is shifting to the right. All right, so we'll call this S1 because that's the one that we're about to move. All right, we'll shift this one to the right. Now this time, this is a very happy outcome. The price went down and the quantity went up. So they're going in opposite directions, but in such a way that that's very nice for the consumer. You're getting more of the product and at a lower price. So that's something, a cause for celebration, really, because now you can have more of this product at a lower price. And that's because somehow the supply increased, maybe technology improved or maybe productivity went up, but that's all to the good. It's like the ideal outcome, best case scenario. But then on the other hand, a decrease in supply would be just the opposite. This is precisely what we do not want to see, because then, as you can tell, the prices will go up and we'll have less of the product. So if there's a severe shortage, for example, of tomatoes, that means your pizza is going to become more expensive and there'll be less of it made and you'll have to pay more for it. So let's take a look at how that would look on a graph. So this time the supply curve will shift to the left. The demand curve is not moving. So we got the first equilibrium is here. 0.1, and then 0.2 is over here. And the curve shifted to the left. Whoops. You don't really need this, but I like to put it in there just to remind you which you're moving in. And so you can see, whoops, bad news. The price went up, the quantity went down. So we don't like this at all. Like I said, you see this sometimes when you get shortages of products. Like, for example, not too long ago, there's major damage to the vanilla crop in Africa. And so suddenly it becomes more expensive to bake cakes. And so they become more expensive because the vanilla is so costly. And God help us if chocolate ever went through that. Imagine if the price of everything containing chocolate went up. You'd be very unhappy, wouldn't you? I bet you would. All right, now what's next? Oh, okay, here's some conceptual questions, but we still could benefit from drawing some curves. What's the relationship between quantity supplied and demanded when there's a shortage? Now, it doesn't, again, say you must draw this picture, does it? No, but why not? It's good practice. So remember what a shortage means. There's not enough of the product for everybody. So if this is your equilibrium, which is where we should be, the shortage means the price is too low. Let's call that P2. And so here's the problem. If you look across, you can see the demand curve is to the right of the supply curve. This is your, I'll tell you what I'll do. I'll call this QD and QS, which clearly are not equal to each other in this case. QD is clearly greater than QS, and by which I mean, by the way, this is quantity demanded. And this is quantity supplied. And in this case, this implies a shortage. And so when there's a shortage, what has to happen? When there's a shortage, QD exceeds QS, or you could write it as QD. QS is less than QD. It doesn't really matter. So that's all they want to know in part A. What is the relationship between quantity supplied and demanded when there's a shortage? The shortage implies the quantity demanded exceeds the quantity supplied. Now, even if you didn't draw the picture, that's fine, as long as you know this part. The quantity demanded is greater than the quantity supplied, but you should also understand that this is caused by the fact that the market price is too low to be in equilibrium. Now, is this situation going to persist forever? No. Smart producers will see this and say, there's room for us to raise our price. And that's exactly what they'll do. All right. So it would be like, imagine if a gas station one day said, let's see how many customers we can get in here, and they lower the price to $1. Well, you know what? But with no time flat, all their gas would be gone. And so they have to wait for their next delivery. And in the meantime, they realize, maybe that wasn't such a smart move. Let's put the price back up to $3, and then we'll have a balance between quantity supplied and quantity demanded. So in part B, the follow-up question, what happens to the price when there's a shortage? The price has to rise. Okay, and that's it. That's the bottom line. When will it stop rising? When we reach equilibrium. So the market will take care of itself. It'll automatically adjust to bring us back into equilibrium. And then it'll stop adjusting. All right, now, what about a surplus? Well, of course, this is just the opposite case. Let's take a look at this one with a graph. So we have an equilibrium, of course, right here. But unfortunately, whoops, Q1, and also this one is going to get in the way. Let me move it over here. All right, so, but the price is too high for some reason. The seller is asking too much. So in this case, we have the opposite scenario from before, namely that QS exceeds QD, and that's what we call a surplus. Okay. I actually would like to put that in here too. This was a shortage. Okay, so now what? So when there's a shortage, a surplus, as you can plainly see, the quantity supplied exceeds the quantity demanded. And that's all that you really needed to say for this question. All right, now what happens as a result to the price? The price has to adjust. It can't stay like that forever. So when there's a surplus, of the good, the price will fall. End of story. And when will it stop falling? When we've reached equilibrium. Okay. So again, a lot of this was optional, but I really think that drawing the picture can help a lot. Okay, but if it doesn't actually say to draw a picture, you don't have to. All right, very good. Now here, we don't have to draw anything. What are three factors that can increase the demand for normal goods? So when it says three, that means you only need three, but I'm going to list all of them anyway, and then you can decide which ones you want to use. Now, in a normal classroom setting, if we were in an exam, you'd be sitting there without any resources except your pen and your paper, and you basically would then have remembered three of the most obvious factors. But here, because you're doing this at home, it's not quite as important to remember all this stuff. But I'm just going to list six of them. Whichever ones stick in your memory, you can use those right here. Okay, so any three will do. Just remember, I'm giving you six now, but you only need three. All right, so number one, an increase in the taste for the good. Okay, just like we've seen over time, people wanted more and more organic products. They want healthier products and they want less tobacco. We know that for sure. So, but that's a separate case. We'll look at that separately. But what can increase the demand? More higher tastes, and that can be caused by a lot of things. And sometimes people just change their taste over time. I mean, not products that used to be very popular are not so popular anymore. It happens. Things come and go in fashion. All kinds of products that we used to, see consumed quite a bit are not quite so popular anymore. Increase in income, perfect. And because it does say that it's a normal good, that means an increase in income. And of course, we know why, because spending money is fun. Okay. We know that we should save, but spending is fun. So when people have more money, they're going to buy more things. It's just as simple as that. Okay. Now, this is the one that's very tricky. You have to be very careful to avoid tricking yourself with this one. An increase in the price of substitutes or a decrease in the price of complements. It's so easy to get these backwards. If you are having an issue remembering which is which, try to think of an example. I'll just throw this in here. You don't have to do this. For example, if the price of Pepsi rises, the demand for Coke will increase because they are substitutes. If the price of ketchup, hamburgers rises, the demand for ketchup will fall because hamburgers and ketchup are complements. Okay. So hamburgers are more expensive. You know what? Actually, let's write this backwards, because we're trying to see what causes the demand to go up. So let me change this to, if the price of hamburgers falls, the demand for ketchup will increase. Okay, because remember, we're aiming for increases in demand. Okay, so if suddenly, let's say beef is much cheaper than usual, people will eat more hamburgers and therefore they'll also eat more ketchup. All right, so with substitutes, the price of a substitute like Pepsi goes up, you'll buy more Coke in this case. But if the hamburgers become cheaper, you're going to want to buy more ketchup because you don't want dry hamburgers, do you? No. So when you buy hamburgers, it's understood that you're also going to buy more complements like ketchup. And you can make the case maybe for pickles too. Who knows? More burgers implies more pickles. There's all kinds of things it can imply, or hamburger buns, for example. There's a lot of possibilities there. All right, let's see. What else do we have down here? Oh, three factors. Oh, wait, I was supposed to do all six of them. Sorry, hold on a second. Number 4 would be the expected future price of the good rises. Okay. So if, for example, if we expect the price of cars to rise significantly in the near future, we may go out and buy a new car now to avoid paying the future higher price. Let's say for some reason the government announces, you know what, we've decided to slap some new taxes on cars. Starting next year, a new car will cost you an extra $1,000 because of this tax. That means you may say, "Ooh, I was thinking about buying a new car anyway. Let me grab one now, rather than waiting to next year." And it happens. When there's stuff going on in the economy that people aren't sure what's going to happen to the supply of a product, that can cause the demand to increase. Now, it may turn out, what happens if that turns out not to be the case? But who knows? But as long as we believe that, then we'll change our consumer patterns accordingly. So in other words, we don't necessarily have to be right about this. As long as we believe that this is going to happen, many people will change their spending habits as a result. All right, so 5. We also had the number, here we go, a simple one. The number of consumers in the market for a good increases. Yeah, just the mere fact that there are more people means that there's more demand for every product. And so that makes the companies happy when they hear that the population is growing, because they say, wow, look at that. That's more Coke customers. Every new baby is a potentially new Coke customer in the future. Okay, and then incomes and or credit increases. Oh wait, no, that's not right. Future incomes or credit are expected to increase. In other words, if you expect to have more income in the future, even before it actually materializes, you may go out and buy more products. Especially, that's a common thing for people who have just started a new job. Yeah, I mean, especially in the early days when you just got started, you're still not making a ton of money, but you have to now go out and get an apartment and clothes and this and that. And so these are the factors that typically cause the demand for a normal good to increase. All right, good. And again, like I said, if it says 3, you can just pick any 3. It doesn't have to be in that order. The ones that you like the best, I guess, you can pick those. Now the supply. So we're going to do the same thing here with supply. Now remember, of course, supply is driven by the profit motive for the most part. Not all goods are produced by profit-making companies, but many of them are. So here our thinking is geared towards making profits. So productivity improves. That's a big one. Productivity, because higher productivity means lower costs of production. The more efficiently we're producing our products, the easier it is to produce them, the more inexpensive it is, the more profitable they are. And so therefore we will make more of that product. Okay, so it's just that simple. So that's why there's always a lot of investment in capital goods. There's a lot of emphasis on improving the technology and inventing new things that increase our productivity. How about 2, input prices? Oh yeah. Okay, this is a classic example. So for example, if the price of oranges declines due to beautiful weather in Florida, the supply of orange juice should increase. Okay. So in other words, if Florida, the weather's even by Florida standards, the weather is more beautiful than ever. That means the crops will grow more quickly, and the farmers will have so many oranges they don't know what to do with them all, and so the price of orange juice should go down. because it costs less for, let's say, Tropicana to make orange juice. Okay, 3. Oh, now, yeah, another one. This is another one that's tricky to think about. A decrease in the price of substitutes in production, or increase in the price of complements in production. Okay, so for example, if a farmer can grow both, let's try something different. I'm tired of corn and wheat. Let's try barley and oats on his land with the same resources, of course. Otherwise, you're not. It's not a valid comparison. And the price of oats falls in the market. The farmer will grow more barley. It's just that simple. So they're considered to be substitutes in production because we could grow either one of them with the same resources. But if the market price of oats starts to drop, we may as well just grow more barley. As far as the complements go, I can't really think of a whole lot of excellent examples of that. So we'll stick with natural gas and crude oil. If the price of natural gas increases, oil companies will produce more oil, because when they, like I think I mentioned this, when they drill for oil, a lot of times those wells also contain natural gas. And so you're getting sort of 2 for the price of 1. So if natural gas becomes more expensive, you may as well drill for more oil and sell more of both, even if the oil hasn't become more expensive. All right, so again, something like this, if it's hard to visualize what this is all about, just try to think of a good example, and then it should hopefully make intuitive sense. Barley, everyone, oats, you've eaten oatmeal. Barley is a grain that you see, you can actually use that to make alcohol, actually. But oats tend to be used for like cereals and things like that. All right, now 4, the price, here we go. The price of a good is expected to decrease in the future. Okay, so for example, suppose that, let's think of a good example of this. Okay, how about this? A farmer who grows crummy ads. All right, so if a farmer who grows, well, let's revert back to that last example, oranges in Florida, realizes that the future price will be lower, or thinks, I shouldn't say realizes, thinks that, because we don't know for sure. You never know what could happen. Next year, the weather could be awful. The farmer who grows oranges in Florida thinks that the future price will be lower. It will make sense for him to increase his output this year to sell as many oranges as possible while the price is still relatively high. In other words, I want to sell them as many as I can before the price starts going down. And then lastly, we have, very simply, the number of producers of a good increases. Okay, so and in markets where there's a lot of profits being made, you're going to see more and more competition. It's just that simple, and then therefore output will increase. So suppose, as an example, if more fast food chains join the market, there will be more fast food being produced, And it's just that simple. So, all right, that's the way that works. Very good. So again, remember, if it says 3, you only need 3 of them, but you should ideally understand all of them. Now this one actually says the magic words show graphically. Graphically means draw a graph. Okay. We want to know the impact on the equilibrium price and quantity of a normal good following an increase in consumer incomes. All right. Well, you know what that means. All you have to do is first figure out what curve is shifting and in what direction, and then show it. All right. So clearly, since this is a normal good, and there's been an increase in consumer incomes, whatever this good is, people will want to buy more of it. So this has nothing to do with the cost of production. So therefore, what's happening here is that there's an increase in demand, right? This is a product that everybody wants. Let's say it's cupcakes, okay? Everybody loves cupcakes. So when their incomes go up, they buy more cupcakes. All right. Maybe not a ton of them because you can only eat so many cupcakes, but people will buy more of them because they're considered to be a normal good. So we've done all these graphs before, but this time it's actually required. Okay, so this time, if it says those magic words graphically, that's your clue that you're supposed to draw it. Which, you know what that reminds me too? Under the circumstances, since we're not actually in the classroom, when there's graphs like this, you clearly can't type them up. So what I have people do is take pictures of them with their cameras on their phones. And for the most part, that works out pretty well. So I assume that you can use your cameras to take pictures of your beautiful graphs. If not, maybe you should practice with them. I guess you figure most people are constantly taking pictures of their phones, but maybe not of documents like this. So just be aware that I don't think there's any other way we can do this. So yeah, it's okay. I mean, I'm sure you can do a good job, but if you do, just make sure that it's clear. Look at the picture yourself and make sure you can read it. Because if you can't read it, I can't read it. And if you're especially proud of your work, maybe you can even put it up on your wall as a poster or something. It looks pretty cool, doesn't it? Yes, it does. Okay. So the increase in consumer incomes increases the demand for all normal goods so that the demand curve shifts to the right. And that's what ends up happening. Okay. Well, that was pretty interesting. Oh, not for a while. It's not at least 2 weeks, let's say. And even then, what we're going to do is, I don't remember, I'd have to double check what chapters are on the first midterm, but we first have to do all the individual problem sets. Like, for example, there's a problem set for chapter 5 that we haven't done yet. And so let's try to do that on Friday. Hold on, let me go get it for you. Now, once those are done, then what comes next is the so-called, what I like to call my sample midterm, which is a big batch of questions from the first, let's say 3 chapters. I think the first midterm is based on just 3, 4, and 5 anyway. So what still needs to be done is we're done with 5, so we need to finish this problem set. And then we'll do the sample midterm. And then I'll post the actual midterm, and you'll have a lot of time to do it. Keep in mind, the midterm was written originally for a class that only lasts for an hour and 15 minutes. So it can't be that overwhelmingly long. It's not, I can only put so much stuff in there. So it's not going to be horrifically time consuming. And it's also not going to be confusing. I mean, everything that is on there will be something that we've done. There'll be no intention to confuse you or trick you or anything along those lines. it'll be exactly, and I mean exactly what we've been doing. So it'll be fine. So my advice to you is do not panic. All right. We're slowly creeping up on it. But once we're done with the review of the sample midterm, you'll be 100% ready for it. And then you'll have plenty of time to not only finish it, but to actually ask questions, either in the class or by email, if you're still not sure what you're supposed to do. Okay, so it'll be fine. Don't worry. All right, so this one's done. I'll post these, of course, in Blackboard when we're through here. You're welcome. So now in the meantime, we've got a little time left. So what I want to do is jump ahead. Oh, we've only got a tiny bit of time left, but I'd still like to at least watch at least one of those videos that I pointed out to you, which are going back to our discussion about government interference in the marketplace and how that affects consumer surplus and producer surplus. So we'll at least start with one of them. And if not, we can finish them up on Friday and then carry on with the rest of the chapter. In fact, let me do this before we get started. Let me go open up the actual, it's here somewhere, the sample midterm. Let's see, where is it? Yeah, you can see there's 15 short answer questions and some word problems. Wow, that's it. That's the whole thing. Oh, you'll have no trouble with it at all. All right, so I'll post this. I might as well post this when we're done too. There's no point waiting around. If you want to start looking at it early, that's fine. All right, so we're going to look at this case of how to produce or calculate consumer producer surplus when there's a price ceiling. We've already seen the video which shows us just in general how to calculate consumer and producer surplus. And if you recall, just a quick review, that what we're actually trying to do is determine how much the consumers are saving because they typically are not asked to pay as much for the product as they're willing to pay for it. And the same thing comes from the producers. They have what we call producer surplus because they typically are able to sell the product at a higher price than they're willing to sell it for. So equilibrium price. So whatever this price is, let's say it's $10, and let's say the quantity is 100. So the consumer surplus is everything from the price line up to that demand curve. Because the logic being that all these people are paying $10 for a product, which they valued at a higher price. Okay, in other words, there's a few people who would have paid 19 and 18 and 17, all the way down to 10. So all of this is our consumer surplus. And then from the perspective of the producers, they were willing to produce this product or sell it for very low prices, but yet they are collecting $10. So that's good for them. And so down here, this region is the difference between what they're earning by selling this product and how much they're willing to sell it for. So this is what we call producer surplus, which I'm abbreviating, of course, and then total surplus is simply the sum of the two. And we've seen that, if there's an interference in the marketplace by governments, this can actually be reduced. Typically, one will go up. Oh, what happened there? I didn't know I could even do that. Typically, when the government intervenes, either one side or the other will gain, but usually the losses of the other side are greater than the gains of the one who benefits from this. And so that leaves us with what we call dead weight loss. All right, we don't want any dead weight loss, do we? No. Okay, but if the prices simply shift around and the demand and supply curve shift, without any government interference, what will happen is if the consumer surplus goes up, producer surplus has to go down by the same amount and vice versa. All right. All right. Anyway, I think we've just got a few minutes left here. So why don't we take a peek at, let's try this one. I don't think this is more than 5 minutes long anyway. Hold on 1 second. All right, I'm going to fire this off to you in the chat room. Let's check this out. I'm pretty sure that we have time to finish this. So let's do this. All right, and as usual, I'll pause the sharing. And so let's watch this. All right. All right, I guess everyone's done. Sadly enough, we've run out of time, so I guess we better get out of here. But all right, so on third, what I want you to do between now and Friday is work on the chapter 5 problem set. And I'll be posting these solutions we did today. Also the sample midterm, if you want to get a look at it ahead of time. So, and then we'll also, of course, get back into chapter 7. So, all right, if there's no last minute, oh, here we go. Oh, okay, yes, I'll see you all on Friday then.
Thank you.
You're welcome.
Thank
Thank
you.
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 Okay, all right, bye. Oh, yeah, go ahead.
I was just wondering when exactly the quiz was.
Well, there's not going to be an actual quiz. I think
Okay.
you're referring to the test. That's not going to be for at least 2 more weeks.
Oh, okay, already, because I was looking at the comments and it said quiz, and I was like, oh,
Oh, no, I think they meant test.
already.
The test is you're gonna do it at home anyway.
Okay, already got it. Thank you.
Okay, bye.